Hello there, folks, and welcome to another update on Iceland's volcanic eruption that's been taking place since March. I'm Geology Professor Shawn Willsey. Thanks for joining me. Today is Sunday, April 14th. It's about 7:30 a.m. here in Mountain Daylight Time, 1:30 p.m. in Iceland, and it's been a few days since I've been able to join you and look through the data together, so I thought we would do that this morning. Hope you're well. Hope you're doing okay. I just had a couple fun days doing field trips with some YouTube viewers, got to meet some folks, and I'll probably provide a little update on that later at a future time. But let's just jump right to what's been going on in Iceland over the last few days. So there's our erupting cone that's still erupting as we speak. The eruption rate has been fairly steady the last few days, but has been, oh, it looks like it's snowing there right now. Classic. Um, but it may be waning a little bit. We may be starting to see this eruption starting to wind down. Time will tell for sure. Another view from a different camera, a little bit clearer, but we can see that the main eruptive activity out of this spatter cone is not only throwing clots of lava around the rim and building up the cone itself, but there is still a basal vent in the cone that's feeding this perched lava channel, and it's sort of ponding out here to the south. We haven't seen any of this lava really progress an appreciable distance away, and that's because the eruption rate, the effusion rate of lava out of the cone is fairly low, and so it can't get much lower than this. If it drops a little bit more, that may kind of just quell the whole thing. So time will just tell. It may keep chugging like this for a while. This eruption began on March 16th, so we're a little over 4 weeks, almost a full month into this phase of eruptive activity. But that's our current status right now, is we still have this thing periodically producing bursts of lava that feed this crater at the top of the spatter cone. Occasionally lava is emitted over the rim of the spatter cone and adds more material to the flank. So let's look and see what's taken place here over the last few days. Let's start with our Met Office update, and this is from the 12th, so this is from 2 days ago on Friday. So the eruption that began on March 16th is constant. Inflation is a similar pace since the beginning of April. Still gases coming out, and let's see, one crater, as we talked about, lava continues to flow south from the crater, but doesn't reach far, and the lava bed continues to build up closer to the crater. So that's that elevated and perched lava channel that we saw in that ponding just to the south side of the crater. No clear signs of lava advancing towards the defensive berms, so that's good news. And yeah, it's continuing to see similar inflation rates over time. We'll get to the GPS data here in a bit. Indicates that the majority of the magma that flows under Svartsengi gathers there, causing increased pressure and landmass. So we think that as this eruption kind of starts to wind down at the surface, more of the magma influx from depth is gathering and being stored in that subsurface chamber versus coming out at the surface. And I'll show you a little diagram that someone's put together that might help show that and explain that a little bit. During the eruption, however, there's still an open connection between the magma collection area in Svartsengi and the Sunnuks crater series. So we still have a continual conduit that allows that magma to make its way to the surface. Variations in inflation can be seen between days, but overall the speed has been constant since the beginning of April. And then they talk about just continued gas emissions and the danger that is posed there. So not a whole lot of information coming out of the Met Office. Again, you can see a lot of gas coming out of this southwest side of the spatter cone, because that's right above this tunnel, this conduit that carries the lava out onto the surface. And so those gases are able to escape vertically through these pores and the permeable nature of this spatter material, and that's why you see all the degassing occurring right there. So let's look at the earthquakes, because yesterday there was an interesting flurry of earthquakes. Of course, the website only collects the last 24 hours, so I would need to go back a little further than that, and that's not possible. But if we start over near Grindavik, there's not a lot going on. There's a little cluster going on over here of very small earthquakes that are quite shallow. Not sure what to make of these just yet, but they're really small magnitude quakes, and quite shallow, but probably nothing to worry about just yet, but something to keep an eye on. And these just popped up, I think, within the last hour or so. But our main eruption area is over here. So these are just to the east, or excuse me, west of Grindavik. But yesterday, the thing that was causing quite a bit of interest in Iceland, in this part of Iceland, was a flurry of earthquakes, really just one large earthquake, and I would even call it large, one felt earthquake of magnitude 3.3 in this area at the south end of Lake Kleifarvatn. And this is, of course, part of the Kleifarvatn system, this northeast, southwest trending volcanic system. And so, of course, with an erupting volcano nearby and a flurry of earthquakes not too many kilometers away, the obvious thought that many people jumped to was, well, is this flurry of earthquakes another sign that an eruption might be taking place? And so there was a magnitude 3.3 here yesterday on Saturday, and then a series of aftershocks. And you can't quite see the pattern as well with just the 24 hours, last 24 hours of data, but there was a clear sort of northeast southwest trend to these locations when they showed up. We can see a bit here on the Met Office update. We can more or less see the location of these. It doesn't show up quite as well with their map, but there's that main 3.3 with the green triangle. Grindavik's over here, and then there was sort of a trend of these quakes running northeast southwest. You can see when those occurred time-wise, so not much seismic activity on the whole peninsula. And then there's that big 3.3, and then you can see all these aftershocks clustering in time shortly thereafter, some of which approached magnitude 2. Many people felt the 3.3s, including our good friend Amanda Joe. And then here's this little cluster that just popped up, literally as I was preparing this. So I'm kind of on the fly wondering what this means. But this little red cluster here that just took place within the past hour or so is that same cluster that we're looking at over here. So maybe at the end of the update, sort of in real time, we can come back to these and look at these, because they are quite small, but they're quite shallow, and we haven't seen, I don't remember anything quite like this that's taken place. It very likely could be, maybe a magnitude 1 or a little bit greater and some aftershocks. I don't think it's indicative of anything more right now, but something to keep an eye on, because that's an area just north of the naval transmitter where we just haven't seen many earthquakes. And so, interesting. We'll have to keep an eye on that. If that continues to trend that way, we might see something potentially. Again, just it's too early to say for sure, but that's an interesting spot. So I totally plan to mainly talk about during this update the earthquakes yesterday in Kleifarvatn. And now I'm kind of drawn to this little cluster here. But let me stick with the Kleifarvatn ones for now. This was in the news as well in Iceland, so a 3.3. And the Met Office made the same conclusion I would make, and that is that these quakes by themselves are not indicative of anything in terms of magma, in terms of eruption activity. These quakes are about 5 kilometers in depth. And the trend that they produced, I think, also speaks to them most likely being tectonic in nature. Remember that many weeks ago, I don't remember which update it was, but I did put together, or I didn't put together, a viewer put together, and I showed you a sequence of earthquake data. I think we started in like 2009 and went till, up till this fall, 2023. And you can just see these earthquake swarms kind of come and go. So remember, we're looking at an active plate boundary that's, with tectonic plates spreading. That plate boundary has many segments to it. And this area near Svartsengi and the area that's erupting is just one of many segments. Those segments do not, for the most part, work together. They're somewhat separate in terms of their earthquake behavior and eruptive behavior. And so we should expect that at any point along these segmented plate boundaries there to be, different types of earthquake activity. And so I thought, just maybe to illustrate this a little bit, to maybe calm some folks down with this specific area near Lake Kleifarvatn and the Kleifarvatn system, I pulled up a paper from 2000. Well, the paper's from 2014, but the focus of the paper is on activity in the Kleifarvatn area in 2009. And so they're looking primarily at the focal mechanism solution. So they're looking at the earthquakes that took place over an active period in 2009 and 10, and what kinds of faults were producing those earthquakes. It's the beach balls again, which I know some of you enjoy. So let me just show you what I really want to show you, I suppose, is this. And this is a map view and then a cross-section view of 2,800 earthquakes in both the Kleifarvatn and just to the west in the Fagradalsfjall region from May to October of 2009. So just look at how many earthquakes were happening here, and at no point at that time, was there an uproar or much to do about this potentially culminating in an eruption. So I'm just trying to show that these earthquake swarms and these periodic, moderate earthquakes and their aftershocks are a regular occurrence here, and they don't always precede eruptions and volcanic activity. So you can see them on the map here, and so how they cluster in two-dimensional space. And then when we look at their depths, we can see that they're right around that, from about 5 to 6 kilometers up to maybe 2. So that same depth that we're looking at with this last earthquake that took place yesterday. And then you can also see that they do define trends, nearly vertical trends that probably correspond to the faults that are producing these quakes. And so you can see some of these steeply dipping faults show up on this plot of the seismicity here. In terms of the types of earthquakes they see in both regions, the lion's share of them are oblique faults. So that means that they're moving both laterally, side to side, horizontally. That's a strike slip fault. But they're also moving vertically, up and down. That would be normal and reverse faults. And so there's a good chunk of them. The majority are oblique slip faults, but then there's also some up and down faults as well, and then also some strike slip faults as well. So, but yeah, they just plot up different clusters of the beach balls, the focal mechanism solutions, to understand the seismic nature there. So that's it for the paper, but the main thing there was just to show you with this one paper that these clusters of earthquakes have happened at many different times in this region around this lake. In fact, this one here, they also detected, along with the earthquakes, if we go back here, there was also uplift. So they had not only earthquakes in 2009, but they had uplift that continued until the fall of 2009. So not only were they getting earthquakes, they had uplift and earthquake activity. But then the uplift reversed in the fall and the area started subsiding. The point is that these periods of uplift and subsidence are common in these volcanically active regions. The earthquakes in and of themselves do not necessarily indicate that an eruption is going to happen soon. The uplift in and of itself does not indicate that. We really need to see a lot of data converging towards that before we're ready to possibly point to some sort of eruption taking place. So hopefully that helps a little bit. Just wanted to address, Amanda Jo had said there was a lot of people quite reasonably a little bit on pins and needles, I suppose, feeling that earthquake, looking at the cluster around Lake Kleifarvatn and wondering if that was going to produce an eruption. So let's look at the GPS data. This is Svartsengi. So again, January, February, March, April, our times along the bottom. Our Y component here on this graph is showing uplift. So any time a red dot moves up on the graph, that means that the ground has risen. And we interpret that ground uplift in this region because we have very good data to suggest that this station sits on or above the shallow magma body that's feeding the eruptions. And so here we can see the inflation in January, culminating in the February 8th eruption. The land sunk back down after that eruption because we moved some of that magma to the surface. And then it started inflating again. And then here we have the March 16th eruption, the one that's still ongoing. And this is the trend line we're looking at now. And early on, it was hard to tell exactly if there was inflation happening. But now with a good month's worth of data, we can see there's clearly an upward trend to this line, to these data points. Not nearly as steep as what we've seen previously, but inflation is still going on, which tells us that there's more magma coming into this shallow magma body than is being erupted at the surface. So we're starting to store more magma in the subsurface, and that will lead somewhere, right? That will lead to possibly another eruption, maybe in the same place. It's hard to say where this is going to go because this is a little different trend. And with this ongoing eruption of a month now, this is a little bit different place than what we saw with the December, January, and February eruptions. And so you can see we've got maybe a good, what do we have here? Maybe about 30 plus millimeters of uplift since the eruption began. And it's gone in fits and starts, a little bit upward trend here, somewhat static and nearly non-upward motion here. But then the last few weeks, there's been a nice little tight trend of upward motion, and then the last bit here you could argue is maybe slowing down a little bit. So it seems to be incremental, not steady motion, but the clear trend line here is upwards, and we can see that with other stations too. I'll just show a couple here. Here's one of the Blue Lagoon stations, definite upward trend there. If we go over to the Elverp station, we can see upward trend there as well during that same time period. So all the signs are showing towards magma now being stored in the subsurface, as well as some of it making its way up to the surface and erupting from this last spatter cone primary vent that we see here. Okay, so that's some of the GPS data. And then a viewer sent this to, I don't know if this is Bruce Garner again. This was sent to me by Amanda Joe. And she didn't tell me which viewer had sent this to her, so I don't know who to give credit to. But this, and they didn't give me any instructions how to play with this, but I think I figured it out a little bit. This just shows the GPS data over a period. So in this case, the person has had a start date of April 3rd, an end date of April 10th, and what we'll be able to see here, let me zoom out a little bit so you get yourself oriented. Here's a Grindavik. Here's the area where we believe the magma body lies underneath the Svartsengi Blue Lagoon region. And these are different GPS stations here, and the lines coming out of them are showing which way it's moving. And I'm assuming that the longer the line, the more the movement. So if we let this play, this will just start, and I think it's just a cumulative movement from April 3rd to April 10th. So just a few little time series there, but it does show the direction and then how much more it moves. So it does speak to a little bit what we saw with those GPS graphs, in that the movement of the GPS stations is sort of in fits and starts right now. There's times when it's moving more quickly, times when it's moving more slowly. But it does show you, you can see some of these stations moving apart from each other. And so presumably that's magma accumulating in the subsurface between those two, kind of like bread rising, as that magma wells up, pushes the ground up with its heat and thermal buoyancy. Two stations on either side of that dome are forced apart. They're moving up, but they're also moving away from each other and apart. And then it looks like they've got other periods as well. So we can look at like March 4th through to March 18th. So remember, this is leading up to the March 16th eruption. And so it's kind of a handy way to look at the data over time, just a way to kind of animate the data and see how it kind of moves. So I'll have to play with this a little bit more, and maybe this person will email either Amanda, Joe, or I and give us some more information on exactly how we can kind of look at this and how we could play with this. So last thing or thing or two here is this is on a Facebook page of some folks in Iceland, and so it's in Icelandic, but there is a English translation here, and I want to walk you through their little diagram here. The attached drawing shows the relative position of the magma storage zone. So we have our depth over here in kilometers, magma feeding into this from the deeper mantle plume source. But what they have here is, according to analysis by the seismic group at Uppsala University, the deeper magma source zone is at 8 to 12 kilometers depth beneath Fagradalsfjall. So that's this larger magma body here. This storage zone is about 10 kilometers wide, and the orange envelope, so this little orange oval around this thing, indicates the crystal mush zone. So this would be magma it's at least partially crystallized into rock. So it's not completely molten material. It's in contact with the surrounding crust, and so it's somewhat cooled a little bit here. It contains rather primitive magma. These results contradict early assertions about it residing in the upper mantle or at depths in excess of 15 kilometers. So remember, previously we kept hearing that the main magma storage zone was further down here, and they now have some evidence from their seismic group that it's at a shallower level. Continuing on, the shallower magma storage zone is significantly smaller. So now they have one up here. Here's, I guess S is Sunnukur, so that's where we're erupting the volcano. F is Fagradalsfjall. Grindavik sits more or less here in this cross-section view, kind of from northeast to southwest, and then the Eldvarp area over here. So the bigger magma body seems to be a little bit shallower, based on their results, than where we thought previously, but it feeds a smaller, shallower magma body here, and this is the one that's causing all the inflation. So this magma body here is the one that's causing the land to rise here. And so right now what we have is, if the way they've drawn this cartoon and this diagram is that we have a conduit coming from this deeper, larger zone, and some is being fed into the shallower storage zone. That's why we're having uplift there. But some is also following a pathway right into the erupting vent right here. When this shallow magma storage zone has filled up, so when this thing's filled up with about 10 to 15 million cubic meters of magma, the roof is ruptured and magma flows upward to eruption. Let's see what else they have here. And we have found that the chemistry of these two eruption sites is very similar. So we do think they're connected to a larger and common magma storage zone at depth. Let's see, anything else here? Yeah, let's see. Yeah, the land at Svartsengi rose. At this point, the magma pressure was large enough to rupture the roof, and the magma flowed rapidly out of the shallow storage through the conduit and just to the southeast of Stora Stogafelt. Yeah, so they've got some stuff here, just kind of about how this has kind of all progressed over time. But I thought this visual would be helpful, and to show you kind of their depiction, highly simplified, of course, as to what might be going on underneath the area. So bigger storage zone here. This shallow one is the one that's producing the uplift and some of the signals that we're seeing that are allowing us to at least model and hopefully forecast when this thing might be erupting. So that's what I have for you so far for the science. On more of the human front, Amanda Jo sent me this article about some of the homes in Grindavik, the people that have agreed to have their homes bought by the government. Those purchase agreements are going through, and so that is in the works right now. Some of those homes are in the process of being transferred over to the country, or some holding company, I suppose. And so those people are able to actually sell their homes. So that's good news for those people that have wanted to sell their homes, is now they're getting the revenue, the money for their sold home, and they're able to kind of move on with their lives. And another interesting story is that they have decided to reopen some of the trails into the Fagradalsfjall area to the public. Now, to get over there, I didn't pull up Google Earth. Let me pull up Google Earth real quick here and show you where this area is. Excuse me. So to get to this area, remember we have these older eruptions from 2021 to 2023. But to get into these parking areas, to hike into these regions here, presumably you're going to have to drive around on Road 42 by Lake Kleifarvatn, and then you can hit the South Coast Road and then access these areas. There's still no access to the public through Grindavik or along this road here that goes to the north. But once you're over here, there are parking areas that have been established, like this one here, and then you can hike in on these trails and at least visit some of these flows and this topography from the last 3 eruptions. And I think maybe from some of these high points, I think the article also says you do get a distant view of the eruption area and these younger lava flows over here to the west. Let me go back to the article and make sure that's the case. Yeah, this action allows visitors to access the hiking trails. Oh yeah, please note, from Path A, there is good view to the ongoing eruption. Visitors are asked not to approach the new eruption site from Fagradalsfjall as it is closed to the public. So, just making sure everyone's aware that even though this area is being open to the public, making sure we don't screw things up by having people try to hike, cross country over to here. There's big cracks in the ground from the earthquakes. It's closed, and they just don't have the manpower to manage that much safety considerations. So hopefully that was helpful. Just wanted to give you some information, do another update with you on our situation here in Iceland. Looking forward, I will probably do another update this week, probably even a live stream where we can talk a little bit about the Iceland eruption and also maybe tackle a few other things, maybe circle back to the volcano Askja in the north. I have some interviews with some folks coming up in the next few weeks, so I want to make you aware of some of the other programs and videos I have going on. So until next time, we'll see you. Thanks for joining me for this update on Iceland, and take care.